Sorry, I was late. I was doing some few up and down. So today's class will not take much time. So let's start. So we want to look at variables for today and then see how variables are being declared. And then the main reason why you should declare your variables whilst you are doing your programming. So we'll look at what variables entails, what they are, and then why we should be able to declare our variables in our programming. So variables and data type. So in our computer programming, a variable is just an identifier. So this variable can be a letter, it can be a word, or it can be a phrase that is linked to a value stored in your computer's memory. Or this your variable can also be an expression that can be evaluated. Because, for example, you can say that your expression pi r square should be stored in a particular variable called a, which we are saying area. So in this case, our area is a variable that is storing the value pi r square. So your variable can be an expression that will have to be stored in our computer memory. In your microcomputer application, I'm sure you all know what memories are, and then the role that computer memory plays in our computers. So without your computer memory, you cannot run any program. Or before programs are being run, it must be loaded and put in your memory before it can be run. So that is the importance of your memory. So as a programmer, you have to make sure that you optimize the use of your memory, because memory in those days was very, very, very expensive. Not now that you can just use 20 CD and you get about 8 gig of memory. In those days, memory is very, 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 very important. Memory is very expensive. So as a programmer, you need to be able to optimize the use of your memory. And one way you can do that is by declaring a variable and assigning it a data type. So shortly, we'll look at how data types are, and then why, when you declare a variable, you need to assign a data type to it. So for example, you can have a variable that you can call total count. So this word here, total count here, is the name of our variable, or it is an identifier that contains a number. Because let's say I want to count the total number of students in class today. So I'm going to declare a variable called total count. So anybody that comes to class, it will keep a record of that person. So today, all of us that are in this Zoom session now are 34. So the total count will be equal to 34. So this 34 is a number, and this number is being stored in our computer memory. And then identifier that we are giving to it is a total count. So you realize that in naming your variables, there are some rules that you should use whenever you are naming your variables, which we will look at shortly. So variables are just names given to storage location in your computer memory, and then they are used to store data temporarily. You know, variables store data temporarily. So once your program stops executing, the content of your variable is lost. That is why we say that they store data temporarily. So for example, they can be used to store the result of some calculation or some text. So as we move on, you guys will realize that when you run one particular program, let's say the area of your circle, which is pi r square, you store that value in your area. And then when you run again, maybe the first time you run, your area is 20 centimeters square. And then when you run again, you realize that it's 15. So you realize that the content of this area, which is a variable, is not static, but rather it is dynamic. And then it keeps on changing depending on what value the user has entered at one particular point in time. So variables, as the name suggests, we say that the content of it keeps on changing. That is why we are referring to it as variable. So the content of your variable will change. For example, if we are running a program and then we say enter your name. So if I enter my name, which is Francis, and then when we run it again, another person enters, and that person is Praise. You realize that at the first time that I entered my name, the variable that is storing my name has the name Francis, but when Praise wants to run it, she will enter her name Praise. So in this case, you realize that the name variable here that is storing the name of our value will keep on changing. So you have to know that the content of your variable keeps on changing. So the value of the variable is lost as soon as the program terminates. So as you see, once you finish executing your program and then the main function returns 0, then the content of whatever you stored in your particular variable will be lost. So in our imperative programming language, values can generally be accessed or changed at any time. So as a programmer, you have that opportunity to change the content of your variable at any given point in time. So maybe you can write a piece of code that can change the content of your variable. Maybe, for example, you are storing the cumulative GPA of students, and then you realize that one particular student has always been present in class. So you write a program that if your total attendance is, let's say, 45 out of 50, then add +1 to the total score for the student. So you realize that in this particular case, you as the programmer, you have the opportunity, or you can change or you can access the content of the variable at any given time. So that is called the third point, that in imperative programming languages, values can generally be accessed or changed at any time. So depending on the type of system programming, variable may only be able to store some specific data types. So as we move on, we will learn what data types are. So depending on whatever you are doing, you as a programmer, you have to assign some kind of a data type to the program that you are running. So you realize that, for example, name of student have to be text or have to be a string, and then the age of the student has to be a number. So depending on what you have, that will determine the kind of data type that you are going to assign to the variables that you parent. So alternatively, a data type may be associated only with the current value, allowing a single value to store anything supported by the programming language. So we'll move on and then we'll see the various types of data types that are being supported by our C++ language. So there are many types of data that we come across in our daily lives. So as you are all aware, today, most of you are taking your phones. Most of you went to your banks to take money. Most of you did a whole lot of things with data. So some of them will be names, will be the address. So maybe you meet somebody and then you take the name. So you store the name, the address, and then money, date, stock code, statistics. These are the various kinds of data that you're going to come across whenever you are doing your coding. So when you come across money, how you handle money in your code will be different from how you are going to handle date. And then how you handle date will also be different from how you handle names or even numbers. So that is that is where our data types comes into place here. So in C++, we have to deal with all sorts of data. Some of them can be mathematically calculated, while others have to be a form of text or other forms. So how do you deal with those ones? So the best way you can deal with those ones is by assigning what we refer to as a data type to those data that you come across. So the data type that you assign to your variables will tell the compiler the kinds of operations to perform on them or how you are supposed to handle them. For example, if it is a number, then the way you are going to manipulate that number will be quite different from if it is a string that we are going to have. And then the same thing also applies to if it is money. How are you going to handle those ones? So that is why you must be able to declare your variables and then assign a data type to it. Because the data type here tells the compiler how it should handle your data. If you have any question, you can raise your hand and I'll allow you to ask the question. Okay. So when programming, we store variables in our computer memory, but the computer has to know what kind of data we want to store in them. This is not going to occupy the same amount of memory to store a simple number than to store a single character or a large number. And they are not going to be interpreted the same way. So as I've said, the reason why you are assigning a data type to your computer, to your variable, is that it will help the compiler in knowing the amount of space that is going to be there for it in memory. So it's just like when you are an usher in church, when somebody that is so big is coming to sit, you know the kind of space that you are going to give to that person. And then if somebody is so slim also coming, you know how to give, or the space that you are going to give to that person. So for example, you have a big space and then you have a small space. And then somebody which is so small is coming, and then you go and put that person in the big space. What you are doing is that person is not going to occupy the entire space. So you are going to waste that space. So the same thing also happens in your computer memory, or in declaring your variables. So when you declare your variables, all that you are telling the computer is that I have a variable that I'll be accessing or I'll be picking from the user, but that data that I'm going to store has or can occupy only 2 bytes of memory. So please reserve 2 bytes of memory in space for me, and then name that memory space that you reserve for me with the variable or the identifier that you are naming. So this is the reason why you must declare and then assign a data type value. And then the data type you also assign will tell the computer or the compiler how it's going to be interpreted. So the interpretation of your data or your variable will be dependent on the data type that you assign. So in our computers, memories are being assigned in bytes, and then you guys know what byte means. So a byte is made up of 8 bits, all right? And then the byte is the smallest or the minimum amount of memory that we can manage your programming. In this case, your C++. So whenever you are trying to manipulate any memory, you are doing them in terms of bytes. So when you assign a variable, you are just telling the computer that reserve this amount of bytes for me to be able to store this variable or this data that I'm going to take from my users. So what are the various types of data types that we have? So data types that we have can be divided into this following group. So we have integers, we have floating point numbers, and then we have alphanumeric. So you all will agree with me that the kind of data that you deal with, either they are numbers or they are numbers that have a decimal portion, and then they are alphanumeric. So for example, if I ask you what is your name, you tell me that your name is Praise, and Praise here is characters. So that one is going to be alphabet. But there are some people whose names are not only alphabet, but it is a combination of alphabet and numerics. So for example, Alpha 277. So in this case, how do you store that particular person's name, Alpha 277? So in this case, you are going to store it as alpha numeric. Or better still, let's say in your code, you want the user to enter a password, and this password must be a mixture of both numbers and alphabet. So in that case, how are you going to handle that particular data? So it's going to be alphanumeric. And then if I ask you what is your age, so you tell me that you are 21 years. So in this case, 21 years, how do I handle that 21 years as your age? So I'm going to handle it as an integer. And then I'll tell you what is your current CGPA or your CWA. Okay, so when you guys finish your first semester, you are going to be having your GPA. So some people's GPA will be like 2.6. So if it is 2.6, how do I store this your GPA so that the decimal portion will also be part of the number? It will not be only 2 but 2.6. So in this case, I'm going to store it as a floating point number. So when we move on, you guys, you are going to realize that the decimal portion of our numbers are so very, very, very small. Consider a variable that is going to store a GPA for you. So if somebody's GPA is 2.6 and then I declare it to be integer, then that means that it's not going to store the 0.6. And then you know how important 0.6 is to you for your GPA. So in this case, you are going to make sure that the 0.6 is stored as part of the GPA of the student. So in this case, you are going to declare the variable as a floating point number. And then there are some numbers that are so huge, or some floating point numbers that are so huge. For example, 3.12222 recurring. So if you want to store those recurrent values, then in this case, you are not going to store them as a floating point number, but that one will have to be a double. So we'll look at those ones shortly. So these are the various types of data types that we have. And these data types usually represent the constraints that you place upon the interpretation of the data in the system. So if I declare a value, for example, GPA to be float, then that means that I'm trying to tell the value, the CWA or the GPA, that any value that is going to store must have a decimal portion. And then if it's having a decimal portion, and then I'm doing some kind of calculation with it, it must contain the decimal portion. Okay, so that is what we mean by having some kind of constraint put on your data. So your data type tells you the constraint that you put on it, the interpretation, and then the structure of the values that are going to be stored in it. And then also your data type also helps you to check the correctness of your computer program that access or manipulate the data. So for example, if I declare a variable, say character A, or child my grade, and then the grade here, because it is character, I'm expecting either A, B, C, or D. So if I enter 1, 2, 3, 4 into it, the compiler will flag me an error because I didn't declare that variable to be of the type integer, but rather of the type character. I hope you guys are following.
Yes, sir.
Okay. So
yes, sir, we are following by. You have some noise in your mic.
Sir.
A noise from my end.
Yes, please. Sometimes it's breaking.
It's breaking. Okay. Then that one is clear.
So it's just some future noise in the background.
Then maybe it's the fan. I'm using the fan. There's a fan in my office. That's what is giving you that pretty noise.
Okay, thank you.
All right. So a byte, as you are saying, the smallest amount of memory that you can handle in your C++ is a byte. So when we talk of this byte, your byte ranges from 0 up to 255. So any value that the size in memory has to be from 0 to 255, because our byte will be able to store. But sometimes you realize that you need to manipulate, or you need to handle complex data. Use something like pictures. You know, pictures usually they don't occupy between 0 to 255. So in such a case, how are you going to handle those kinds of numbers? So you realize that those types of values or numbers that you are going to manipulate will be so much greater than the byte. So we have different types of data types that support all data that you have. So when you are declaring your variable, these are the types of data types that you can assign or to your variables. And then this is the size that is going to occupy in your memory. So for example, if I say char, so char here represents character or small integers. Usually it occupies only 1 byte of space in my memory. Okay, so it can be signed and unsigned. So when we will look at what is meant by signed and unsigned briefly. So the char, when you declare a variable to be char, then that means that it's occupying only 1 byte in memory. Then if it is short int, it's having 2 bytes. Int is integer, is having 4 bytes of memory in space. Then long int will also have 4. Boolean will have 1 byte, because that one is only taking 2 values. Either it is a true or it is false. So we have Boolean, which is true or false. Then we have float. So float here will occupy 4 bytes. And then you know what floats are. If you want to store the decimal portion of any number that you want, if it's going to be too small, you declare it as float. But if it's going to be too big, the floating point, the decimal portion is going to be about say 15 digits, then you declare it as double. Then we have long double also take 8 bytes. Then we have the WeChat-T, which takes Y characters. So that one takes 2 or 4 characters. So these are the various data types that you should use in declaring your variables. So now identifiers. So we are saying that our variables are just identifiers, and these identifiers can just be a phrase, a letter, or it can even contain expressions that we have in our computations in our programming. So these identifiers are just lexical tokens that name an identity. Okay. So in computer language, identifiers are tokens which usually are symbols which name language entities. So your entity here can be anything at all that you can think of in the real world. So anything that you want to represent in your computer system can be an entity. So which name are you giving to that particular entity? That ID that you are assigning to it is what we refer to as the identifier. So some of these identifiers can be variables. So we are looking at variables. So it can be a type, it can be a label, it can be a subroutine, it can be a package. So in this course, we will look at subroutines and types, but packages will be left for the high-level programming language to look at next semester. So variables, you can use your identifiers to name your variables, your types, the labels, your subroutines, and then your package. So naming entities make it possible to refer to them. So it's just like when you were born, you were kept in a room for 7 days. So when people come to visit you, they just say baby girl, baby boy. But we can continue using that name for you. So when you are growing, they give you a name, for example, Praise. But when you come to the school, we don't want to be calling you Praise. So we have also given you an ID. So that ID now becomes your identifier. So anywhere that we want to identify you in the school, we make reference to that particular ID. So you realize that when you are also programming, when you are going to have any variable, that variable that you are going to use, you must give it an ID so that subsequently you can be able to reference to that particular ID or that variable. So that is how come we need to be able to give an ID to our values. So now these identifiers, how do you name them? There are some rules that you must use in naming some of these identifiers. So the first rule is that any valid identifier should be a sequence of one or more letters, digits, or underscore. So for example, if I want to store name, I can say that my I can have an identifier this way. I can have an identifier this way, call it my name. So I can say my name. So this my name here can be an identifier for me. Somebody can also decide that I will not name it my name, but I will just say N. Somebody can say, okay, let mine be NM or NN names. So that is why we are saying that any valid identifier you have must be a sequence of one or more letters. So over here, you can see that it's made up of more than one. Here is one, it's valid. Here is also made up of one. So I can say name one. So you can see that it also contains what? Digit. Or better still, I can say name, my name, underscore one. So you see my name, then I have underscore this way. That is what we mean by this first statement here. Then the next one is saying that neither spaces nor punctuation marks or symbol can be part of an identifier. So as you can see, I cannot name my name and say my name and then I have a space here one. it is not allowed. I cannot say my name and then bring a symbol this way and say my name question mark 1. It is not allowed. I can't use any symbol or punctuation. It is not allowed. When you do that, your compiler will flag you an error. Only letters, digit, and single underscore are valid. So you can see over here, if you want to bring your question mark or any symbol, then you need to bring an underscore. So you can see I have an underscore 1 here. Or better still, you can say underscore my name. So in this case, underscore my name here is a valid way that you can name your variable. In addition, variable identifiers always have to begin with a letter. So you can go and say 1 my name. You can do it that way. You can say 1 my name. When you do this, the compiler will flag you an error. Or question mark my name, the compiler will flag you an error. So these are the rules that you're supposed to follow whenever you are naming your identifiers. So another rule that you need to consider when inventing your own identifiers is that it cannot match any keyword of the programming language or the compiler specific ones. So in C++, we have some words that we refer to as keywords. Those ones are reserved. They are for only the compiler. For example, there are some words in Ghana here that it is only the president and the vice president that will use those words for. For example, Your Excellency. So I cannot come to class and say, Your Excellency, let's say John Blay Osabote. I cannot do that. Okay. There are some reserved words. Those reserved words are only to be used by the compiler. So when you are naming your variable, make sure that you don't name your variable using those reserved words. So examples of the reserved words are float, double, int. So as we move on, you will learn more of these reserved words. These reserved words, you cannot use them to name your identifier. When you do that, your compiler will flag you an error. One thing you must also note is that C++ language is a case-sensitive language. Case-sensitive here means that identifiers that you write in capital letters is not the same as the one that you write in small letters. So, for example, result. You see this variable here, result. You see this is capital letters. It's different from this one here, result. And then also, it is also different from this. So, for example, this one, this result is different from these R results, and then also different from this result. Also different from this. Result. So all these things are valid variable names. They are all not the same. They are all different. This is capital. This is capitalized. And then this is small letters. So you realize that when you are naming your variables, because of the case sensitivity of our C++, this, the first one is different from this. This is also different from this. So you have to keep this in mind that because of the case sensitivity of our C++, this is different from this is also different from this. So now, how do we declare our variables? So we see variables. Say variables are just placeholders in memory. And when we are declaring variables, you must use a valid identifier and then you must assign a data type to it. So in your code, how do you declare the variable? So I told you that before you make use of any variable in your computer program, it must first be declared. So the syntax for declaring our variable is to write the specifier of the variable desired data type, followed by a valid identifier. So for example, this one here, int a. So the int here, the int here is telling us that the variable that we have, the name is a, or the identifier is a, but the data type is integer. So the integer here specifies the data type, and then is followed by the valid identifier, in this case a. Then I have another one also known as float my number. So when I see float my number, this float my number here is my number is the variable name, and then the float here is the data type that I have. So this my number is declared to be of the type float. This a is the variable of the type integer. So this is how you declare your variable. So the syntax you use is you have the data type followed by a valid identifier. So there are two valid variables. So as we've just seen, we have two variables that we declared. So the first one that we saw declare a variable of type int, and then the identifier was a. The second one that we saw has the data type float, and then the identifier was my name. So once you declare your variable, they can be used within the scope of the program. So we'll shortly look at what we mean by the scope of a variable. So once your variable has been declared, it can be used within your program. But if you don't declare it and you are using it, your variable will flag you an error. So it's just like you open school and you didn't register. If you didn't register and you write exam, it's invalid. All those your scores will be zero. So you need to be able to register first. So your way of registering the variable is by declaring them. So you must make sure that you declare the variable before you use them in code. Now, we have different ways that you can declare your variables. So as you can see from here, this one here, we declare A, B, C. All of them are variables, and all of them are of the type int. So as you can see, A, B, C. So this is what we refer to as single line declaration. Okay, so we declare A, B, C, all of them on a single line. The reason why we are doing this is because A, B, C, all of them are of the same data type here, known as the int. You can do the same thing this way. So in this case, this is multiple line declaration. Int A, then you terminate it. Int B, you terminate it. Int C, you terminate it. So this is the same as this. If they are going to be of the same data type, you can declare them on one line, or you can just separate them, each one of them be in a different line. So the one that is convenient for you, you stick to that option. Then the integer data types, star, short, long, int can either be signed or unsigned. So what we mean by signed and unsigned is that, you'll be dealing with negative values and then you'll be dealing with positive values. So sometimes you need to be able to show that this variable should contain both positive and negative, or should contain only positive numbers. So in that case, how do you show that? You show that by using either signed or unsigned, depending on the range of value that you want to represent. So when we say a signed type, they can be represent both positive and negative. So if you want to represent both positive and negative, then it has to be a signed type. But if you only want positive numbers, you don't want to include the negative, then in that case, you declare them using unsigned. So for example, if you look at here, we say unsigned short int number of sisters. So right here, you see number of sisters here is the variable name, number of sisters. And then over here is unsigned short int, because you can have a negative number of sisters. So you can have either a 0 sister or you can have a positive sister. So in this case, that is how come we declare here as unsigned short int number of sisters. Then the second declaration shows signed in my account balance. You can go to your bank and your account balance will run into negative. So if your account balance is running into negative, we should be able to show that your account is negative. It can also be in positive. So in this case, we want my account balance to store both positive and negative values. So in that case, we declare it as a signed in my account balance. So this one here shows that my account balance can hold positive and negative, but unsigned means that it can only hold positive or a 0 number. So that's the meaning of the signed and then the unsigned data types. So what do we mean by the scope of a variable? So when we mean scope, all variables that we intend to use in a program must be declared with a specified identifier and an earlier point in the code, like we did in the previous ones where we defined A, B, C, and then result. All of them were of the type int. So when we talk of the scope of a variable, what we mean is that the scope is where that variable is visible within the portion of your code that we are writing. So when you are writing your code can either, your variable can either be of a global scope or it can be of a local scope. So when we talk of a global scope, then that one is declared in the main body of the source code or is declared outside of the function. But when we talk of a local variable, then that one is defined within the body of a function or a block. So what we mean by that statement is this. Let's say that we want to declare a function, and then one thing you must note is that when you declare a function, let's say int a, the a is my function, okay? Anything that occurs within these braces here will be declared or will be defined as being a local to this particular function. So in this case, let's say I declare a variable called my name. I declare a variable called my name, and then let's say I say string. Let's say string my name. So I terminate it here, and then I say float GPA. Let's say CGPA. Okay, float GPA. So what I have done here is that variable here, my name, and then my GPA, because I have defined them within this block, between here and here, they are local variables. So local variable here means that they can only be accessed within this portion. When I come outside this, I cannot access them because they will be termed as global. So any function, any variable that you declare outside this curly bracket here will be termed as a global variable. So for example, if I said if I say double my result, double my result. So in this case, my result here is declared as a global variable. And global variable, you can access them anywhere. I can come here and access my global variable. I can come even to the top here and access my global variable. So one thing you must note is that global variable are accessed anywhere within your code. But before you use them, you must be able to declare them. So this is what we mean by local and global variable. So your local are declared within the body of the function or within a block. And then if it is defined outside of it or declared in the main body, then in that case, it becomes our global variable. So these are our differences between the global and local. Local is declared within a function, and then any variable that is declared outside of the function or within the main body of the function is what we refer to as the global variable. So now let's look at this. So we have hash include iostream using namespace std, int integer, char a character, char string. We'll look at this shortly, maybe in our next class. That's arrays. Then unsigned int number of sons. Then you see that in the int main, we have some variables also, age, a number, and another number. So this a number, age, and another number are known as local variables because they are declared within this function here. But you see that this one, a integer, the string, and then number of sons, they are global variable because they are declared outside of it. So that will tell you what our global and local variables are. So global variables can be referred from anywhere in the code, even inside a function. So once you declare them, even you can go and access them within the body of a function. So a global variable is just like a global system. For example, the United Nations boss, the UN Secretary General, that entity is considered to be a global variable, a global citizen. He does not need any visa to come to Ghana or to go anywhere in the world. But you know, the two of us, we are local citizens. We are just Ghanaians. Before we go outside of our country, we need a visa before we can go. So the same thing is what is happening with our global variable. So with a global variable, anywhere at all that I go or within your functions, you can go and then access them. So the scope of a local variable is limited to your closed block or this one. So once any variable is declared within these curly braces, mind you, it is declared as a local variable. Okay, so I think that ends our discussion for today. If you have any question, you can ask. Any question? Do you have any question?
Not really, sir.
Okay, so I think that the concept of variables is well understood. So before you use any variable, you must make sure that you declare the variable. And then in declaring it, you need to specify the data type and then you pick a valid name. And then we saw the rules that you're supposed to use whenever you are trying to define the valid.
Please, I want to know if I want to be learning the computer programming ahead of the class, which books do you recommend for me?
Come again? Abubakar.
Like, please, where can I get our books, download them, and I'll be learning small stuff because it's not, I'm supposed to have the theory, then I'll be reading it.
Do you have the course outline? I share some of the books that you can get on the course outline. So maybe you can try and see whether you can get those books on Amazon or anywhere that you can get them. Okay, I share some books. Anthony.
Sir, good afternoon. Good morning.
Sir, please, where can we get those books?
Oh, those books, if you go to, you just Google them, you know, some of them you need to pay before you get them.
Yes, sir.
Yeah, some of them you need to pay before you
like the principles of programming books.
Yeah, so that's what I'm saying, that go to Amazon or where, I mean, there are a lot of places you can get some of these books to buy. So
Okay, sir.
yeah, even if you go to EPP book in Accra, I'm sure that you can get those ones.
Sir, but please, if you go to Accra, like bookshops, can we get?
Oh yeah, why not? You can get.
Okay, sir.
Yeah, you can get them.
Thank you, sir.
Please, sir, please, I just maybe this specific book, and then I'll go to the internet.
Which one? The one that I'm using the slide. Ibrahim. Okay. Yes. Hereford.
Sir. Yes, sir.
Ask your
Sir,
question.
like I've already asked. That's what I asked. That can we get at the bookshops?
Oh, all right. So
Hello, sir.
yes. Someone want to ask the question again? Okay.
Yeah.
Yes.
Please, the question mark. What if you want to use it in maybe in a variable? How do you do it?
Yeah. So I told you that if you want to use the question mark in your variable. So for example, let's say that let's say total score. So you are declaring a variable called total score. Total score. Okay. So if you want, just bring how do we call it? Underscore. Bring your question mark. But why do you want to name a variable this way? Okay, they say it shouldn't contain any symbol. So why won't you just make your life so simple by just declaring your variable as total score this way? Is this thing not nicer than complicating yourself by saying something like this? You see, so don't complicate yourself. Just go simple, and then you are off. Okay.
Okay.
All right. So next week, what we'll do is that we'll put all these things into practice, and then we'll declare variables. We'll see how we can take an input from the user and then manipulate them and then give the output to the user. Okay. So if you don't have any questions, I think we'll stop here.
Please, the assignment, the one that you give to us,
yeah.
Should you send it as JPEG or how do you do it?
No, I mean you just you screenshot it and you paste it in Word. Okay. So from next week I'll give you assignment. So those assignments that I'll give, I'll show you how to present them. Okay. You copy the code, you put it in Word. So after the code, then you screenshot and then you put the result also just below it.
Hello, sir.
Thank you.
Yeah.
Sir.
Yeah.
Some of us came in late. We were waiting and we just came in late. Will the video be made available to us?
Oh, yes, I'll make the video available.
Thank you, sir.
Okay, so if no further question, we'll stop here and then we'll continue next week. But you have to be prepared for your midterm. Okay, so maybe immediately after Easter, we'll look at our midterm. Okay, so Easter will be on the 17th, 18th. So after Easter, which will be 23rd, we'll have our mid-semester examination. All right, so just prepare for it. All right, I'll see you next week. Bye.